Hello everyone, in this video we're going to solve another question which is A+B+C subsequences. Now this question is a string question with a bit of DP with it, right? So if you look at the object of the question which is over here, and if we take this to the page and read it out to understand what the question wants from us, it says that you are given a string str and you are required to calculate and print the count of subsequences of nature A+B+C+, right? So you have to count the total number of subsequences such that all of those subsequences follow a certain rule of a certain type, which is A+B+C+ nature, right? So the key word over here is the nature of A+B+C+. What does this mean? This means that every set of A's would be followed by a set of B's, which would be followed by a set of C's, with a constraint that for all the number of A and B and C in the subsequences is greater than or equal to 1, right? Is it clear? Doesn't matter. We can take a sample input over here and we can say that for, let's suppose, A, B, B, C, the number of subsequences that follow the nature of A+B+C+ are abc, A, B, B, C, and abc again, right? In this, if I give badging to both the B's, let's suppose this is B1 and this is B2, the very first string is my AB1C, the second was AB1C, B1 B2C, and the third one is AB2C, right? So these are the three total subsequences that follow the nature of abc, A+B+C+, right? Over here, if you look at it, we have A followed by a B followed by a C. Then we have a single A followed by two B's and then a single C. In each of these subsequences, there is at least one character of each type and they follow a certain rule. That is, A's come, then B's come after A's, and then C's come after B's, right? So over here also, if you look at the examples that are being given, for ABBC, which we just discussed, there are 3 subsequences. For ABC, we have 7 subsequences, right? So I hope you understand the question now, and I would want you to try it out for yourself first. And if you get stuck somewhere, please take the help of either the video or the editorial that has been provided. Okay, so moving on to the solution of this question, right? So as it's a DP question, again, I would reiterate what we have to do. Very first thing, assign storage, right? Assign storage. Second thing, get a certain direction in which we want to work on. And the third one is, of course, traversing and solving in that direction to get the answer, right? Now, before doing all of this, we have to get an idea of what we are working with generally, right? So what I would say is that if I have, let's suppose, A plus subsequences, what are the ways in which I can create A plus subsequences from a given string? This is only if I add a at the end of nothing, at the end of a single string. So by this, I would cover a case of a single A, right? Okay. Or what I can do is I can add A to all the subsequences that are already of A plus order. In that way, if I have multiple consecutive A's, I'm just adding another A at the end of it, right? It would still be of A plus type, right? What if I want to create a string of A plus B plus type, right? In this case, I would add a B, I would add a B. It can be either at the end of an A plus subsequence, or it can be at the end of a plus B plus subsequence, right? If I have a subsequence which is of A type, so I can have A, anything, right? Any times of A, right? I can just add B at the end of all of them, and I would get a plus B plus subsequence. Or else, by the second case, what I want to say is that if I have a plus B plus subsequence, which is A, B, 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 something, right? B, 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 I can just add a B to it, and it will still remain of the type A plus B plus subsequence. Right? I hope this is clear. I hope this is clear. So in the similar fashion, let's discuss about A plus B plus C plus, right? For A plus B plus subsequence, I have to add C. I can add C at the end of either A plus B plus, or I can add C at the end of A plus B plus C plus. Right? If I have A plus B plus, I can add just a single C and convert it into A plus B plus C plus subsequence. If I already have a plus B plus C plus subsequence, I can add another C at the end of it. It would just be consecutive C's at the end, right? So I hope this is clear, and this is the way in which we can create subsequences of a certain type. Understandable? Now we are going to use this concept to build a DP and to solve it, right? So what I'm going to do is I have this DP over here, right? This DP is of size of the string. Over here, if you see, this is the string as input. I've taken this string as input, and at this string, I would have 3 DP arrays, which are A plus B plus, A plus B plus C plus. For now, we would just look at the way I'm traversing and solving. And at the end of it, we would discuss what ways we can execute it, what ways we can program this, right? So if I talk about this position, right, this position, which is A plus B plus till A dash, this would mean the number of A plus B plus type of subsequences that are possible till this position in the string. So for string A, B, C, A dash, the number of subsequences it could generate of type A plus B plus, right? In similar fashion, what would this mean? This position would mean the number of A plus type of subsequences that the string A, B, C, A dash, B dash could generate. So the string till over here of this type, right? So the number of subsequences of this type till the string over here at this point, right? So again, if we think about it, what would this symbolize? This particular point in the DP would contain the total number of A plus B plus C plus subsequences that could be generated with the entire string. Isn't this the problem statement of the question? The problem statement of the question is the same as the meaning of this particular point in the DP. That is the possible number of A plus B plus C plus subsequences that are possible from the entire string, right? So here we would have our answer. This would be our base case, and we would be moving in the forward direction. So till now, what we have discussed, we come over here. What we have discussed till now is that we have assigned the storage, and we have discussed about the direction. What does that storage mean, and the direction in which we have to move. The third part is traversing and solving. So let's quickly traverse and solve, right? So over here at index 0, so this is 0, 1, 2, 3, 4, 5, just the indexes, right? At index 0, we have character A. Can my character A be used to make a subsequence of type A plus? Yes, it can. We can make a single subsequence A. As we saw over here, we can use a single A on an empty string, and we can have single A as A plus subsequence, right? So we can have A over here. Can I use my A to make A plus B plus subsequence? No, we can only use B to create a plus B plus subsequence. Similarly, we can only use a C to create a plus B plus C plus subsequence. Right? I hope it's clear. This is what we derived over here. Right? We can only use a, you see over here, we can only use a to create A plus B plus subsequence. We can use only a B to create a plus B plus subsequence, and we can use a C to create A plus B plus C plus subsequence, right? So if we come back over here, I would say that we have one possible subsequence, right? So what I'm going to do is I'm going to write this more properly, erase this. I would say this is my count 1, and over here I can say that A is something that we created, right? Now at this point, the number of A plus B plus subsequences remain 0 and 0. This is because we were not able to create any subsequences of that type, right? So moving on to the first index now. This index is over. Moving on to first index, right? First index, the character is B. Can we use B to make A plus subsequence? No, we cannot. So my A plus subsequences, the number of A plus subsequences would remain the same, which is A itself, right? Now, can I use a B to create A plus B plus subsequence? Yes, I can. And how can I do that? I can either add B at the end of my A plus subsequence, right? I can either add B at the end of my A plus subsequence, which is A. So I can add A and then B, right? This is A plus B plus subsequence. So I get one from here. Or what I can do is I can add B at the end of all the A plus B plus subsequences that I have, right? Over here, the number of A plus B plus subsequences was 0. So we cannot add B at the end of anything. That means the total number of subsequences over here would be 1, which is just adding B at the end of A, right? And as we cannot use B to create A plus B plus C plus subsequences, it remains to be 0, right? I hope it's a bit clear what we are doing, right? Moving on to the next index. So this index is something that we have done. So moving on to next index, which has a character of C. C can be used to make the subsequence of type A plus B plus C plus. We cannot make A plus or A plus B plus using it, right? So this would remain 1, this would remain 1. And the types, the strings are A, B, A over here, right? So exactly the same as previous state. What we want to change are the number of A plus B plus C plus subsequences. Now, how can we create A plus B plus C plus subsequence? We can add C to either A plus B plus subsequences or A plus B plus C plus subsequences, which we discussed over here, right? Right? Scroll back in the video, look at this once again, and you would clearly get what we are trying to do. We can add C at the end of either A plus B plus or A plus B plus C plus, right? We discussed it with examples over there, right? So again, we can add A C at the end of A plus B plus, which is AB. So what we can have as A, B, C over here, right? And this would get my count to 1. Then I can also add C at the end of A plus B plus C plus, but as in the previous state, it's 0. We cannot add anything to 0, right? We cannot add C directly to a blank string. That is only possible for A. Okay, moving on to the third position, right? The third position, which has a character A. A can only change the type of A plus. We have nothing to do with A plus B plus or A plus B plus C plus. So we can directly write both of them again over here. So we have AB and ABC. Now, when we have A dash, what we can do is we can either have A dash with a blank string, right? Or we can add A dash to the previous string, right? So we can have over here, if I erase this, what I'm trying to say is I can either have A dash alone or I can add A dash at the end of A, right? Is there any other possible subsequences that are possible? At this point, there is a possibility that we don't consider A dash at all. And in this case, the number of the subsequence that we would get is a single A, right? So clearly see what happened. A dash said that I can either attach to an empty string or I can come with the previous subsequences. It came alone over here with previous subsequences of A plus type over here, which is A dash, and then it said, okay, what if I don't come at all? In this case, the previous subsequence that was just A persists forward, right? This gives us a total of 3 subsequences, right? So there are 2 choices with A dash, right? There are 2 choices. What are those choices? Those choices are that my A dash could either come alone, which would be just one choice. That is, it comes with an empty string, right? So if my A dash comes with an empty string, I would get A dash alone. Or my A dash could pair up with A plus subsequences in 2 ways. It can either come or not come. That means it has 2 choices. So I would multiply A plus types with 2 and add 1, right? So this would be my new A plus types, right? This is what we did over here. If we see, what I did over here was 2 into 1 plus 1, which is 3, right? I hope this is clear. I hope this is clear what I'm trying to say. And if we move to the next index over here, right? So if we move to 4, which has B character. Now, B character can only change the type of A plus B plus subsequences. That means the other two would remain exactly the same. A dash, A dash, A over here, and A, B, C over here. Now, what does my B dash say? B dash says that what I can do is I can come after A plus subsequences, which are all of these. So what I can do is I can have A dash, B dash. I can have A dash, B dash. I can have A, B dash, right? These three. Or I can come after A plus B plus subsequences, which are AB. So I can have A, B, B dash. And another possible subsequence is that I don't come after A plus B plus type. That means I would just have AB over here. So if you see, we have a total of five subsequences, right? And again, what we did over here is that my B dash had options. What options? Either it can come after every possible A plus subsequences, or it had a choice of either coming after the A plus B plus subsequences or not. So this would be my formula for my new B plus subsequences. If we verify this over here, what we have is 2 into 1 plus 3, which is 5. Right? Let's quickly move on to the last index that we have, which is of character C. Right? For character C, I can only change A plus B plus C plus type of subsequences. Okay. Now, C can either attach itself at the end of A plus B plus subsequences. Then, in that case, what I would have is A dash B dash C dash. Right? A dash B dash C dash. Right? Then A B dash C dash, A B B dash C dash, and A B then C dash. Right? So all of these 5 get C dash attached at the end of them. Right? Another possible way for me to create A plus B plus C plus type of subsequence is when I could apply C at the end of all the A plus B plus C plus type of subsequence. Then it would mean abc C dash, and another option, of course, if I don't attach myself. So A, B, C in that case. This brings the count total equivalent to 1, 2, 3, 4, 5, 6, and 7. Hence, over here, the total subsequences are 7. Right? As this was our very last index, this should be our answer. Right? And if we come over here in the question, for the given input of abc, which we took right now, the output was 7. Right? And these are the exact similar subsequences that we see over here. Right? Again, what we did was for C plus, the possibility for a C, the possibility is that it can either attach itself at the end of A plus B plus, or it has two other choices of attaching or not attaching itself at the end of A plus B plus C plus type. Right? This would be my new of C plus. Now, if you observe another thing, it's that at any given point, we are using only a single previous state. We are not, for calculating 5, we are not using these states. We are only interested in the 4th state. Right? So we just need a single state. That means we just need 3 different variables to solve this question instead of an entire array. Right? So if we see how we can do this question, we come over here, and what I have to take input is a simple string. So scanner sc is equal to new, I should full screen this. So new scanner system.in, right? Then I can have my string str equivalent to sc.next. Now what I have to do is assign variables, right? So let's call my variables as a, right? 0, int b, ab equals to 0, int abc equals to 0. These three variables are associated to different types. So variables of different types of subsequences, right? So a is a plus, ab is a plus b plus, then we have a plus b plus c plus, so on and so forth. Now we have to calculate from 0 till nth, which is the length of the string. So for int I equals to 0 till str dot length plus plus, right? Now at this point I will have my character from the string, which is c. So let's see over here, which is my character, right? Now I have three cases. If my c is a, then I have to make changes in a, variable a. If my character c is b, then I have to make changes in ab, right? So what I would do is, first of all, I would have over here, if my c is equal to a, then I have to do something. If my c is equal to b, then I have to do something. Else if my c is equal to c, then I have to do something, right? Over here I have to make changes to my a. How can I do that? I have to create a new a, which would be a 2 into a plus 1, right? And then I have to assign new a to a. Over here I have to calculate a new ab, twice of ab plus a, and then assign new ab to a, right? In the third if else block, when I have character as c, I would calculate new a plus b plus c plus type of subsequences, which is new abc, which are 2 times of abc plus ab, and then I would assign this value to the initial variable, which is abc. So new abc would be assigned to abc, right? At the end of this, as we discussed, our answer lies at abc, right? So I would get my total a plus b plus subsequences in abc variable, and if I run this, so it works, right? If we submit this for all the test cases, and it should work, right? So it does, right? So we were able to solve this question with just these derivations over here. How can we form a plus subsequences, then a plus b plus subsequences, and then a plus b plus c plus subsequences? Then we looked at the DP of the problem, and then we also observed how we can make it space optimized. So if we talk about the time and space complexity of this particular question, we were able to solve this in a single for loop. That means it is of O of, right? And initially we used three arrays, integer arrays of size n in our approach, but further we realized that we can do it in constant space because we need only a single previous state to solve further states, right? So we were able to do this in O1 space complexity, right? I hope the question is clear to you, and I will see you in the next video. If you like the video, please share it with your friends. I'll see you. Bye bye.